September 4th, 1940, 12,000 feet above the Kent countryside. Flight Lieutenant James Nicholson of 249 Squadron wrestled with the controls of his burning Hawker Hurricane as cannon shells from a Messerschmitt 109 tore through the cockpit. Shrapnel pierced his foot, flames erupted around him, yet Nicholson refused to bail out. Through the smoke and fire he'd spotted a German bomber in his sights. Ignoring the searing pain, he pressed the firing button. 8 Browning machine guns spoke as one, and the enemy aircraft spiraled earthward. Only then did Nicholson throw himself from his disintegrating fighter, his uniform ablaze. He would become the only fighter command pilot to receive the Victoria Cross during the entire war. The aircraft that brought him home through impossible odds, that absorbed punishment no other fighter could survive, was not the glamorous Spitfire that dominates historical memory. It was the Hurricane, the workhorse, the forgotten champion, the aircraft German pilots would learn never to underestimate. This is the story of how an obsolete fighter transformed into the most feared ground attack aircraft of World War II, and how those stubby, fabric-covered wings would rewrite the rules of air warfare. The Hurricane's story begins not with glory, but with quiet determination. While the Spitfire captured headlines with its elliptical wings and sleek lines, Sidney Cam's Hurricane was an engineer's aircraft. Built around a tubular steel frame and covered with fabric, it seemed a throwback to the biplane era, a transitional design already outdated before the war began. Test pilots who flew both fighters invariably described the Spitfire as a thoroughbred racehorse, responsive and temperamental. The Hurricane, they said, was a workhorse. Solid, forgiving, utterly dependable. It was not a compliment they meant lightly. When war erupted in September 1939, the Royal Air Force possessed 497 Hurricanes, far outnumbering the 187 Spitfires in service. This numerical advantage was no accident. The Hurricane's old-fashioned construction, deemed a weakness by aviation enthusiasts, proved its greatest strength in mass production. While Spitfires required complex stressed skin construction and precision metalwork, Hurricanes could be built quickly using techniques familiar to any aircraft manufacturer. Repairs that grounded a Spitfire for weeks took days on a Hurricane. Battle damage that would write off a Spitfire could be patched overnight with fabric and basic tools. The aircraft's wide track landing gear made it forgiving for inexperienced pilots, reducing training accidents. But none of this mattered to German fighter pilots, who first encountered Hurricanes over France in May 1940. They saw only a slower, more cumbersome opponent than their Messerschmitt 109s. The Hurricane Mark I, powered by the Merlin II engine, producing 1,030 horsepower, could manage perhaps 315 miles per hour in level flight under combat conditions. The Messerschmitt 109E could reach 354 miles per hour. In a straight chase, there was no contest. German pilots quickly developed contempt for the British fighter. Lieutenant Franz von Werra, who would later become famous for his escape attempts from British captivity, wrote in his diary after his first encounter with Hurricanes, "The British send up these lumbering machines against us. They cannot catch us in level flight. They cannot follow us in a dive. Their only hope is to turn, and what good is turning when we can simply climb away and attack again at our leisure?" Von Werra's confidence was not misplaced. The Hurricane could not match the 109 in speed, climb rate, or dive performance. Yet, during the desperate Battle of France, Hurricane squadrons claimed 409 enemy aircraft destroyed against their own losses of over 200 fighters. The statistics seemed to suggest parity, perhaps even superiority. The reality was more complex. Post-war examination of German records revealed actual Luftwaffe losses of 299 aircraft to RAF fighters during this period, not the 499 claimed. Overclaiming was universal in air combat, where multiple pilots often fired at the same target, and the chaos of battle made accurate assessment impossible. But even accounting for exaggeration, Hurricanes were proving far more dangerous than their performance suggested. The key lay not in the aircraft's speed, but in its purpose. While German fighters sought aerial combat, Hurricanes hunted bombers. The Hurricane's sturdy construction made it a stable gun platform. Its 8 Browning machine guns, though only 303 caliber rifle rounds, created a devastating weight of fire when properly aimed. At convergence distance typically set at 250 yards, all 8 gun streams intersected in a zone roughly 6 feet in diameter. Anything caught in that zone faced 160 rounds per second. Heinkel and Dornier bombers, with their aluminum construction and minimal armour, didn't just get shot down, they came apart. Squadron leader Peter Townsend, commanding 85 Squadron during the Battle of France, described the Hurricane's killing power. You didn't need cannon. The 8 Brownings, when you got them on target, simply sawed through aircraft structure. I watched a Heinkel 111's tail separate from the fuselage, clean as a surgical cut. The aircraft fell in 2 pieces. The bomber crews knew immediately they were dead. The Battle of Britain that followed France's fall would prove the Hurricane's finest hour, though history would remember it as the Spitfire's victory. On July 10, 1940, when the Luftwaffe launched its campaign to destroy Fighter Command, 32 Hurricane squadrons faced the onslaught alongside just 19 Spitfire squadrons. The numerical disparity was even greater than it appeared. Each Hurricane squadron typically flew more sorties than Spitfire units, due to the Hurricane's shorter turnaround time. Reaming and refueling a Hurricane took 9 minutes. A Spitfire required 26 minutes. Over the course of a day's continuous operations, this difference meant Hurricane squadrons could fly twice as many missions. Fighter Command doctrine assigned roles based on aircraft capabilities. Spitfires, with their superior performance, engaged German fighter escorts at high altitude. Hurricanes went after the bombers. It was not the glamorous role, but it was the essential one. Every bomber that reached its target could kill hundreds of civilians. Every bomber shot down saved lives. The statistics of the Battle of Britain tell the story more clearly than any ace's memoir. From July to October 1940, Hurricane pilots were credited with destroying 1,593 German aircraft, representing 55% of all Fighter Command victories. Spitfires accounted for 42%, with remaining credits going to other aircraft types and anti-aircraft fire. Again, overclaiming inflated these numbers. Actual German losses totaled 1,187 aircraft of all types during the battle, but the proportions remained valid. Hurricanes bore the heaviest burden and dealt the most damage. What German intelligence failed to grasp during the battle was that the Hurricane's supposed obsolescence masked qualities that mattered more than raw speed. The aircraft could outturn any German fighter in service. In a dogfight, when a Messerschmitt tried to follow a Hurricane through a tight turn, the German fighter would stall and spin. Hurricanes could also absorb extraordinary punishment. The tubular steel frame that seemed so antiquated provided structural redundancy impossible in stressed skin designs. Cannon shells that would shatter a Spitfire's monocoque fuselage simply punched holes in a Hurricane's fabric covering, leaving the underlying structure intact. The Merlin engine, a massive liquid-cooled Vitiplov, sat behind armour plate and could run for hours with multiple cylinder heads destroyed. Flight Sergeant George Unwin of 19 Squadron experienced this durability firsthand on August 16, 1940. Bounced by 109s over Dover, his Hurricane took 5 cannon strikes and over 40 machine gun hits. The port wing was shredded. The fuselage fabric hung in strips. One cannon shell had exploded against the armour plate behind his seat, the impact feeling like a mule kick, yet the Hurricane flew. Unwin nursed it back to base, landed safely, and watched ground crew count the holes. 47 major punctures, numerous minor damage, yet every control surface still functioned. The engine still ran. Within 18 hours, the aircraft returned to service. German pilots who survived being shot down often expressed shock at British fighter durability. Hauptmann Adolf Galland, one of the Luftwaffe's most successful aces, wrote after the war, "We expected the Hurricane to be easy prey. Its performance was inferior to our fighters in most measurables. What we did not account for was that the British built their fighters to survive, not just to fly fast. A 109 with engine damage fell from the sky. A Hurricane with engine damage limped home. This changed the mathematics of attrition in ways we failed to recognise until too late." Yet, as 1940 gave way to 1941, the Hurricane's limitations became undeniable. The Messerschmitt 109F introduced in the spring was faster, better armed, and more manoeuvrable than its predecessor. The Focke-Wulf 190 arriving in the summer outperformed the Hurricane in virtually every category. Spitfire production finally reached sufficient levels to replace Hurricane squadrons in the pure fighter role. The workhorse seemed destined for obsolescence. What saved the Hurricane from retirement was not sentiment, but adaptability. The same rugged construction that made it a survivor made it an ideal testbed for new weapons and roles. Hawker Aircraft had been experimenting with improved armament since 1940, seeking to address the Hurricane's greatest weakness. Those 8 Browning machine guns, devastating against unarmoured bombers, proved increasingly inadequate against newer German aircraft with armour plating and self-sealing fuel tanks. It was relatively common for Luftwaffe fighters to return to base with 50 or more .303 caliber bullet strikes, the rounds having insufficient energy to penetrate critical components. The solution arrived in the form of the Hurricane Mark II, first flown on June 11, 1940, though not entering squadron service until September. The new Mark featured the Merlin Dex-X engine, producing 1,280 horsepower through a 2-stage supercharger. Top speed increased to 342 miles per hour at 22,000 feet, though combat-loaded aircraft rarely achieved these figures. The real revolution came with the Universal Wing, a redesigned structure capable of mounting various armament configurations. The Mark IIA Series II offered a choice: 12 Browning 303 machine guns, increasing weight of fire by 50%, or 4 Hispano 20mm cannons, trading volume of fire for striking power. The cannon-armed Hurricane Mark IIC, entering service in early 1941, represented a dramatic escalation in firepower. Each 20mm round weighed as much as 25 of the 303 caliber bullets. A single cannon strike could blow a fighter's wing off. 3 hits would destroy any aircraft in the sky. But even more significant than increased armament was the Universal Wing's other capability: it could carry bombs. As Fighter Command transitioned from desperate defense to aggressive offense in 1941, the Hurricane found its true calling. The fighter bomber, or Hurribomber as pilots nicknamed it, could carry 2 250-pound bombs, later increased to 500-pounders. Combined with 4 20mm cannons, the Hurricane Mark IIC became a devastating strike aircraft. It could destroy a bridge, strafe an airfield, engage enemy fighters, and return home through weather that grounded more delicate aircraft. The transformation was neither instant nor easy. Fighter pilots viewed ground attack with suspicion bordering on contempt. They had trained for air combat, not dive bombing. The idea of attacking defended targets at low altitude where every rifle could reach you seemed suicidal compared to the relative safety of high-altitude fighter sweeps. Squadron leader Frank Carey, who flew Hurricanes from France through Malta to Burma, capturing the attitude of many pilots. We were fighters, not bombers. Being assigned to ground attack felt like punishment. Every airfield had flat guns, every convoy had machine guns. You came in low and slow with bombs hanging on your wings, and they just hosed you with fire. We lost more aircraft to ground fire in the first month of fighter-bomber operations than we'd lost in 3 months of air combat. Yet the losses were acceptable because the destruction was catastrophic. A Hurricane with 2 500-pound bombs could crater a runway, collapse a bridge, or obliterate a fuel depot. The 4 20mm cannons could destroy trucks, trains, and light-armoured vehicles. Unlike heavy bombers that required elaborate mission planning and fighter escort, Hurribombers could strike targets of opportunity with minimal warning. The evolution of the Hurricane reached its apex in North Africa, where the aircraft would earn a reputation that terrified German tank crews. In the spring of 1942, 6th Squadron RAF, one of the oldest units in the service, found itself in an embarrassing position. Having given up its obsolete Lysander Army Cooperation aircraft, the squadron possessed exactly 1 Hurricane Mark I and served primarily as a maintenance and ferry unit. The squadron commander, Roger Porteous, wondered if things could possibly get worse. In May, they got dramatically better. The Hurricane Mark II began arriving in Egypt, and 6th Squadron was selected to pioneer the anti-tank role. The Mark ID was a radical experiment. 2 40mm Vickers S cannons, each with 15 rounds of armour-piercing ammunition, mounted in bulbous pods beneath the wings. The internal wing armament was reduced to 2 Browning machine guns loaded with tracer rounds to help pilots judge range. Additional armour protected the engine, radiator, and pilot from ground fire. The modifications added 1,000 pounds to the aircraft's weight and reduced top speed to just 288 miles per hour, with tropical dust filters installed. German fighters could outrun a Hurricane II-ID by 100 miles per hour. But the Mark II-ID wasn't designed to fight aircraft. It was built to kill tanks. Flight Lieutenant Donald Weston Burt, a South African who served as the squadron's second-in-command, led the training at Shandor on the Suez Canal through May and June 1942. The 40mm Vickers S was a semi-automatic weapon. Each press of the firing button fired one round from each cannon simultaneously. The recoil was violent, pitching the nose down and shaking the entire aircraft. Pilots had to compensate immediately, or their next pair of rounds would strike the ground short of the target. Live fire training against captured Italian tanks revealed both the weapon's potential and its demands. A pilot approaching at 240 miles per hour, flying at 50 feet above the desert, would begin firing at 700 yards. The tracers from the Brownings showed where the heavy cannon rounds were going. A skilled pilot could fire 5 aimed pairs of 40mm shells during a single pass before breaking away. Each tungsten cored round could penetrate the top armour of any German or Italian tank in service. A single hit on the engine deck meant a destroyed tank. 2 hits guaranteed it. The psychological effect on tank crews was profound. Armoured vehicles provided protection from rifles and machine guns, even from most artillery except direct hits. Tankers felt secure in their steel cocoons. Then Hurricanes armed with guns that could punch through the roof changed everything. A German prisoner of war from the El Alamein battle later described the experience of being attacked by Hurricane tank busters. "We heard aircraft engines but paid little attention. Enemy aircraft usually could not harm us." Then there was a sound like enormous hammers striking steel, and the tank next to ours exploded. Fire erupted from the engine compartment. The crew tried to bail out, but only the commander escaped before the ammunition cooked off. Another tank was hit, then another. In seconds, half our company was burning. The crews that survived abandoned their vehicles and ran. We preferred to face British artillery rather than those aircraft again. The appearance of British tank busters came as a great surprise to German forces. 6th Squadron flew its first anti-tank missions in June 1942 during the confused fighting around Gazala and Bir Hakeim. Early results were mixed. The Hurricanes successfully destroyed several tanks and numerous trucks, but the aircraft's slow speed made it vulnerable. On the squadron's second mission, ground fire shot down one Hurricane and damaged another so severely it crash-landed. The pilots quickly learned that success required specific conditions. Tank busting worked best during mobile warfare, when armoured vehicles had outrun their anti-aircraft support and operated in relatively open terrain. Concentrated flak made attacks suicidal. Enemy fighters made them impossible. The ideal situation was finding tanks that had broken through defensive lines and raced ahead without proper support. These targets were vulnerable and valuable. Destroying them could stop an entire offensive. The great test came at El Alamein. On October 23, 1942, General Bernard Montgomery launched the offensive that would break Rommel's Afrika Korps and change the entire complexion of the North African campaign. The artillery barrage that opened the battle at 9:40 p.m. was the heaviest concentration of firepower yet seen in the Desert War. Behind that curtain of steel, British and Commonwealth infantry advanced into German minefields. The next morning, as dawn broke over the desert, Hurricane tank busters went hunting. At 10:35 a.m. on October 24th, Wing Commander Wing Porteous led 6 Hurricanes from Landing Ground 89 toward the southern sector of the battle line. Intelligence reported German armour concentrating for a counterattack. The Hurricanes found them. American-made M3 Stuart light tanks captured earlier in the campaign and now operated by German crews. The Stuarts, nicknamed Honeys by British tankers for their reliability, carried thin armour designed primarily to stop machine gun fire. Against 40mm armour-piercing rounds, they were death traps. Porteous lined up on the first tank, began firing at 700 yards, walked his shells forward as tracers showed the fall of shot, and watched the Stuart erupt in flames. The crew bailed out, uniforms on fire. His wingman destroyed 2 more tanks in the same pass. They broke away, circled to regain altitude, and made a second attack. 3 more Honeys burned. The entire attack lasted less than 5 minutes. 6 tanks destroyed. No aircraft lost. 2 hours later, squadron leader Weston Burt led another 6 Hurricane Tuskegee against the same area. They found more captured tanks, a mix of Stuarts and British Crusaders, all now flying German markings. Weston Burt personally claimed 2 Honeys and a Crusader destroyed. The squadron's gunfire camera footage, reviewed that evening, confirmed 8 more tanks ablaze. It was 6 squadrons' most successful day in the tank busting role, and it was just beginning. Over the following week, Hurricane tank busters flew constantly, sometimes 4 or 5 sorties per day. They attacked not just tanks but any armoured vehicle, half-tracks, armoured cars, self-propelled guns. The 40mm cannons proved equally effective against all of them. By November 4th, when the Africa Corps finally began its long retreat westward, 6th Squadron claimed 26 tanks and 31 armoured vehicles destroyed, along with dozens of trucks, guns and other equipment. The squadron had earned its nickname, the Flying Can Openers. German and Italian forces learned to recognise the distinctive silhouette of the tank-buster Hurricanes and would abandon their vehicles at the first warning of an attack. Armour that couldn't manoeuvre was useless in mobile warfare. Better to escape and fight another day than burn to death in a steel coffin. Yet, the Flying Can Opener legend requires context. Post-war analysis revealed that claims of tanks destroyed, by all air forces and all means, were enormously inflated. Pilots and aircrew genuinely believed they had destroyed targets that were, in fact, only damaged or abandoned. Confirming kills from several thousand feet of altitude moving at hundreds of miles per hour was nearly impossible. Ground fire often looked like catastrophic damage when it merely forced a crew to bail out temporarily. Captured German records show lower tank losses than Allied air forces claimed, though the records themselves are incomplete and unreliable. What is undeniable is the psychological and operational impact. German armoured formations in North Africa learned to move only at night or during bad weather when British aircraft could not operate. Daylight movement became suicidal after El Alamein. This restriction crippled the mobility that made armour effective. Tanks sitting still waiting for darkness were targets for artillery. Tanks forced to move on cramped nighttime schedules arrived piecemeal and exhausted. The Hurricane tank busters didn't need to destroy every tank to win. They simply needed to make tank operations during daylight impossible. The Hurricane's ground attack capabilities expanded further with the introduction of rocket projectiles in early 1943. The RP-3 rocket, carrying a 60-pound warhead, could be mounted on rails beneath the wings, 8 rockets per aircraft. Each rocket hit with the force of a 6-inch naval shell. While less accurate than the 40mm cannons, rockets allowed attack from longer range and greater safety. Hurricane Mark the Stu-Cs and IVs equipped with rockets became the most common ground attack variant in the Mediterranean and European theatres. In Italy during 1943 and 1944, Hurricane rocket-armed fighters devastated German supply lines, destroying bridges, trains, and convoy after convoy of trucks trying to move supplies to the front lines. Unlike heavy bombers that required complex mission planning and could only attack targets in good weather, Hurricanes operated daily, hitting targets of opportunity wherever German forces moved. Flight Lieutenant James Storer of 241 Squadron described a typical mission over Italy in February 1944. We flew at low level, following roads and rail lines, looking for anything worth shooting. Found a train near Cassino trying to reach the front during daylight. Foolish. We each carried 8 rockets and full cannon ammunition. The first salvo of rockets destroyed the locomotive. The train stopped. Then we went down the line systematically, rocketing each car, then following up with cannon fire. Ammunition cars exploded spectacularly. Supply cars burned. By the time we finished, the entire train was destroyed. 15 minutes' work. The Germans would need days to clear the wreckage and reopen the line. Similar devastation occurred wherever Hurricanes operated. In Burma, where jungle terrain made supply routes critical choke points, Hurricane ground attack squadrons destroyed hundreds of bridges, cutting Japanese logistics and isolating forward units. The Japanese had few tanks in Burma and minimal anti-aircraft defences. Hurricanes roamed at will, their rugged construction proof against the tropical climate that grounded more sophisticated aircraft. Yet, even as ground attack Hurricanes proved devastating against the enemy, they still needed to defend themselves against enemy fighters. The Hurricane 2C with its 420mm cannons remained a capable air-to-air fighter, though outclassed by the latest German and Japanese designs. The aircraft's excellent turning circle meant that any enemy pilot who tried to follow a Hurricane through a sustained turn would find himself outmaneuvered and facing those 4 cannons. Squadron leader Lance Wade, an American volunteer flying with the RAF in North Africa, before the United States entered the war, demonstrated the Hurricane 2C's air combat potential. Wade scored 23 confirmed victories, mostly while flying Hurricanes against superior German fighters. His technique was simple, but effective. He would allow enemy fighters to attack, confident the Hurricane could absorb the punishment, then use his superior turning ability to reverse the situation. Wade described his philosophy in a letter to his family. The new German fighters are faster, climb better, dive faster, but they can't turn with a Hurricane. Let them make their pass, survive it, then turn inside them. When they try to follow, they stall or spin. That's when you shoot them. German pilots shot down by Wade uniformly expressed surprise that a Hurricane could be so dangerous. The prevailing Luftwaffe attitude held that Hurricanes were obsolete, easy targets to be avoided only because wasting ammunition on them wasn't worthwhile. Encountering a Hurricane pilot who knew his aircraft's strengths and used them ruthlessly was a deadly education. Yet individual victories mattered less than operational impact. By 1943, the Hurricane's role in air superiority operations had essentially ended. The Spitfire Mark IX, the American P-38 Lightning and P-51 Mustang, and even the P-40 Warhawk in certain conditions all offered better fighter performance. The Hurricane found its value in ground attack, a mission that didn't require matching enemy fighters in speed or climb rate but demanded durability, heavy armament, and the ability to operate from rough airstrips under primitive conditions. The Hurricane excelled at all three. Its wide track landing gear allowed operations from unprepared strips that would have wrecked other aircraft. Its simple construction meant squadron mechanics could keep it flying with minimal spare parts. Its radial engine, lacking vulnerable coolant systems despite being a V12, the Merlin's cooling system was more robust than typical inline engines, could absorb battle damage that would down any liquid-cooled fighter. These qualities made the Hurricane indispensable in secondary theatres where operating conditions were brutal. In the Far East, Hurricanes soldiered on through 1945, long after they'd been replaced in Europe. In the Soviet Union, where Britain supplied thousands of Hurricane Mark IIs under Lend-Lease, Soviet pilots initially dismissed the aircraft as inferior to their own fighters. But they quickly learned to appreciate the Hurricane's ruggedness and reliability. Soviet ground crews, infamous for creative modifications to Western-supplied equipment, often rearmed Hurricanes with Russian 20mm cannons or heavier machine guns, improving firepower at the expense of some performance. The most significant Soviet operation involving Hurricanes occurred in defense of Murmansk during 1941 and 1942. RAF Hurricane squadrons operating from Soviet airfields, alongside Soviet pilots, flew combat air patrol protecting the vital Arctic convoy route. In September 1941, these mixed RAF and Soviet Hurricane units destroyed 15 German aircraft for the loss of only one Hurricane in combat. German bombers attempting to attack the convoys faced a wall of Hurricanes that proved far more effective than expected in the extreme cold of the Arctic. Yet, Soviet pilots complained about the Hurricane's machine gun armament. The standard 8 or 12 Browning 303 caliber guns, inadequate against modern German fighters, led Soviet mechanics to remove them and substitute fewer but heavier weapons. These modifications usually degraded overall performance, but Soviet tactical doctrine favoured heavy punch over sustained fire. The Hurricane's adaptability allowed it to serve effectively even when modified beyond original specifications. By 1944, the Hurricane's frontline service was ending in most theatres. In Europe, the Hawker Typhoon and Tempest had taken over the ground attack role, offering more speed, more firepower, and better performance against the German fighters that increasingly challenged Allied air superiority. In the Pacific, American aircraft were replacing British types as production shifted to standardized American designs, yet Hurricanes continued flying until war's end, serving in secondary roles, training units, and remote theatres where newer aircraft weren't available. The final combat missions occurred over Burma in May 1945, Hurricane ground attack fighters supporting the British advance toward Rangoon. The last Hurricane produced, serial number PZ-865, rolled off the production line at Hawker's Langley factory in July 1944. By that time, 14,583 Hurricanes had been built, more than any other British aircraft except the Spitfire. The statistics tell the story of an aircraft that won through persistence rather than glamour. Hurricanes claimed more than 60% of RAF victories during the Battle of Britain, though Spitfires received the glory. Hurricanes destroyed more German armoured vehicles in North Africa than any other aircraft type, though the tanks themselves won credit for most armoured kills in official reports. Hurricanes flew more combat sorties in more theatres under worse conditions than arguably any other Allied fighter. Yet when the war ended, they were scrapped by the thousands while Spitfires were carefully preserved. The difference in historical treatment reveals something fundamental about how societies remember war. The Spitfire represented what Britain wanted to be: elegant, advanced, victorious through superior technology. The Hurricane represented what Britain actually was: pragmatic, resilient, victorious through determination and adaptability. One narrative inspires, the other teaches. The Hurricane's designers never intended to create an icon. Sidney Cam wanted a fighter that could be built quickly, maintained easily, and flown safely by average pilots. He succeeded beyond anyone's expectations. The Hurricane wasn't the fastest fighter, or the most heavily armed, or the longest ranged, but it was the most versatile, the most durable, and perhaps the most important. Consider the mathematics of survival. During the Battle of Britain, a Spitfire pilot shot down had roughly a 40% chance of returning to duty within a week if he survived the bailout. A Hurricane pilot had a 70% chance. The difference lay in the aircraft themselves. Hurricanes were more likely to bring wounded pilots home. Crash landings that killed Spitfire pilots merely injured Hurricane pilots. The wide landing gear absorbed impacts that would flip other fighters. The tubular frame created a survival cell around the cockpit that stressed skin construction couldn't match. Over the entire war, Hurricane attrition rates per sortie flown were consistently lower than comparable fighters, despite operating in more dangerous ground attack roles. This wasn't because Hurricane pilots took fewer risks. It was because the aircraft itself was designed, perhaps accidentally, to maximize crew survival. The Hurricane also democratized aerial warfare in ways rarely discussed. The Spitfire demanded skill. An inexperienced pilot in a Spitfire was dangerous to himself and his squadron. The sensitive controls, narrow landing gear, and unforgiving handling near stall speeds made it a demanding aircraft. Training accidents were common. Pilot attrition in Spitfire squadrons ran higher than in Hurricane units even when accounting for combat losses. The Hurricane forgave mistakes. Student pilots transitioning from trainers to Hurricanes needed less conversion time and experienced fewer accidents. Squadron commanders could put a pilot with 50 hours in Hurricanes into combat with reasonable confidence he'd survive. The same pilot needed 100 hours in Spitfires before he was anything but a liability. This forgiveness multiplied throughout the RAF's training pipeline. More pilots survived training. More pilots reached squadrons ready for combat. More pilots survived their first missions and lived to become veterans. The Hurricane's docility wasn't weakness. It was a force multiplier that British aircraft production statistics alone couldn't capture. The ground attack role magnified this effect. Unlike air combat, where split-second reactions and aggressive manoeuvring determined survival, ground attack required steady nerves, precise flying, and the ability to absorb punishment. The Hurricane's stable gun platform characteristics, originally designed for air-to-air gunnery, proved even more valuable when attacking ground targets. A pilot could hold his aircraft steady through sustained anti-aircraft fire, make minute corrections to aim, and deliver weapons with accuracy impossible in jumpier aircraft. Wing Commander Roland Beaumont, who flew both Hurricanes and Typhoons in the ground attack role, compared their characteristics in his post-war memoir. The Typhoon was faster, carried more weapons, looked more fearsome, but the Hurricane was easier to fly precisely at low altitude. In the Typhoon, you were constantly fighting the aircraft, making corrections, compensating for the torque and the weight. In the Hurricane, you could fly with one hand while looking for targets with the other. For ground attack, where you might spend an hour at 50 feet searching for targets, that made all the difference between exhaustion and effectiveness. The distinction mattered because ground attack missions were not brief dogfights, but sustained operations. A fighter sweep might last 90 minutes with perhaps 5 minutes of actual combat. A ground attack mission might last 2 hours with constant exposure to ground fire. Pilot fatigue became a critical factor. Aircraft that demanded constant attention wore pilots down. The Hurricane's easy handling meant pilots returned from missions tired but functional, ready to fly again after rest. Typhoon pilots often returned on the edge of exhaustion, needing longer recovery periods between missions. This operational tempo advantage never appeared in performance specifications, but determined squadron effectiveness. Hurricane ground attack units regularly flew more sorties per day than units equipped with theoretically superior aircraft. Over weeks and months of continuous operations, this translated to more targets destroyed, more enemy positions suppressed, more support provided to ground forces. The Hurricane's final contribution to the war effort came not from its own operations but from the lessons it taught about aircraft design. Post-war analysis of combat effectiveness per pound of aircraft weight, per man-hour of production, and per unit cost revealed uncomfortable truths for aircraft designers who had prioritized performance over practicality. The Hurricane's Combat Effectiveness Index, a complex metric combining sortie rate, survival rate, target destruction, and production cost, exceeded almost every other fighter in the war except possibly the Soviet Yak-9 and the American P-47 Thunderbolt, both of which shared the Hurricane's emphasis on ruggedness over performance. Meanwhile, aircraft like the Messerschmitt 262 jet fighter, marvels of technology, scored poorly on the same index. They destroyed targets impressively when they flew, but they flew too rarely, cost too much, and required too much maintenance. The lesson was clear: wars are won by aircraft that fly, not aircraft that impress. The Hurricane flew constantly, operated anywhere, required minimal support and brought its pilots home. These qualities mattered more than speed records or climbing rates in determining actual combat value. Yet this lesson was largely forgotten in the post-war era. The jet age arrived, and designers once again prioritized performance over practicality. Early's jets were maintenance nightmares, required extensive ground support, and crashed frequently due to unforgiving handling characteristics. It took a generation of accidents and operational failures before aircraft designers rediscovered principles that Sidney Cam had understood in the 1930s. An aircraft must be not just fast but flyable, not just powerful but maintainable, not just advanced but practical. Modern close air support aircraft like the American A-10 Thunderbolt II owe more to the Hurricane's philosophy than their designers might acknowledge. The A-10 is slow by modern standards, built around a massive gun, armoured to absorb ground fire, designed for operations from rough airstrips, and deliberately forgiving in handling. These are Hurricane characteristics adapted to the jet age. The A-10's designers studied ground attack aircraft history and concluded that the Hurricane's approach had been correct all along. The Hurricane's story, then, is not just about one aircraft in one war. It's about engineering philosophy, about understanding that elegance and effectiveness are not synonyms, that survival matters more than performance, that the aircraft that keeps flying wins over the aircraft that flies fastest. When the last Hurricane was scrapped in the late 1950s, stripped of useful parts and melted down for aluminum, nobody organised ceremonies or preservation efforts beyond a handful of museum examples. The aircraft had done its job. That perhaps would have satisfied Sidney Cam more than any memorial. He had built a tool, not a monument. The tool had worked exactly as intended, for longer and in more diverse roles than anyone had imagined possible. Today, perhaps 15 airworthy Hurricanes remain worldwide, carefully maintained by museums and private collectors. They appear at air shows, painted in the colours of famous squadrons, performing graceful aerobatics that demonstrate the handling qualities that made them such effective wartime platforms. Crowds applaud, photographers snap pictures, and commentators inevitably mention that the Hurricane was the forgotten fighter of the Battle of Britain. But some veterans know better. James Nicholson, the Victoria Cross recipient who stayed in his burning Hurricane to shoot down one more enemy, survived the war and lived until 1945 when he died in a transport aircraft crash. Before his death, he wrote a letter to Sidney Cam thanking him for designing an aircraft that had saved his life. The Hurricane's structural strength, Nicholson wrote, had held together long enough for him to make his attack and escape. A lesser aircraft would have disintegrated around him. Cam kept that letter until his own death in 1966. He never spoke publicly about it, never used it for publicity, never mentioned it in interviews. It was simply confirmation that his engineering had worked as intended. The aircraft had brought the pilot home through impossible conditions. That was enough. The true measure of the Hurricane's success lies not in victory claims or performance specifications, but in those letters pilots wrote to Cam, in the mechanics who could keep Hurricanes flying with improvised parts and determination, in the squadron commanders who trusted the aircraft with their greenest pilots, knowing it would forgive their mistakes and teach them to survive. The Hurricane was never beautiful. It was never the fastest or the most advanced. It was never the aircraft that captured imaginations or inspired poets. But it was the aircraft that won the battle when winning mattered most, that adapted when others became obsolete, that survived when survival seemed impossible. In the end, those qualities count for more than grace or speed or any other measure of aerial perfection. The last word belongs to Group Captain Douglas Bader, the legless pilot who became one of Britain's most famous fighter aces. Bader flew both Spitfires and Hurricanes, led squadrons of both types, and understood their strengths and limitations better than most. After the war, asked which fighter he preferred, he answered without hesitation. The Spitfire was a lady, refined, elegant, a pleasure to fly. But when things got rough, when you needed an aircraft you could trust absolutely, when coming home mattered more than looking good, you wanted a Hurricane. The Hurricane was a fighter you could depend on. In war, that's the only thing that really matters. The dependability Bader described manifested in countless small ways that never made it into official combat reports. Hurricane pilots developed an almost familial relationship with their aircraft, a trust that went beyond professional competence into something approaching affection. This bond was peculiar to the Hurricane. Spitfire pilots respected their mounts. Typhoon pilots fought their aircraft as much as the enemy. But Hurricane pilots loved their Hurricanes with the uncomplicated devotion reserved for faithful dogs. Part of this stemmed from the aircraft's transparency. A Hurricane's mechanical state was visible to its pilot. The fabric covering meant you could see wrinkles and tears that indicated structural stress. The simple systems meant a pilot could diagnose problems from cockpit instruments and sounds. Experienced Hurricane pilots claimed they could hear when their aircraft needed maintenance, detecting subtle changes in engine note or airframe vibration that warned of developing issues before they became critical. Flight Lieutenant Richard Hillary, who survived being shot down in flames during the Battle of Britain and wrote the haunting memoir The Last Enemy, described this intimate knowledge. You learned your Hurricane the way you learned a person's face, every rivet, every panel line, every quirk of the controls. My Hurricane pulled slightly left in a dive. I compensated automatically. When I flew a different Hurricane, even the same mark and squadron, it felt foreign, like wearing someone else's clothes. The aircraft wasn't interchangeable despite being built to identical specifications. Each had personality. This individuality extended to performance. While Spitfires were built to tight tolerances that produced consistent performance across airframes, Hurricanes varied noticeably. Some were faster than others, some turned tighter, some had heavier control loads. Factory records show variations of up to 15 miles per hour in top speed between supposedly identical aircraft due to slight differences in fabric tension, engine tuning, and assembly quality. Rather than viewing this as a manufacturing defect, pilots and ground crews saw it as character. Squadrons developed hierarchies of Hurricanes, with the fastest or most maneuverable aircraft reserved for the most experienced pilots or the squadron commander. New pilots got the sluggish ones until they proved themselves. This informal system, impossible with more standardized aircraft, created additional motivation for pilot skill development. The ground crews who maintained Hurricanes developed similar attachments. Sergeant Jack Jenkins, who served as crew chief for a Hurricane squadron through the entire war, described the relationship in his unpublished memoir. You couldn't just be a mechanic on Hurricanes, you had to understand them. The fabric covering meant you could see inside the aircraft, see how stressed the structure was, see where repairs were needed before anything broke. We'd patch bullet holes with fabric and dope, restitch torn panels, replace damaged tubes in the frame. It was more like surgery than mechanics. You got to know every aircraft individually. When one didn't come back, it felt personal. This maintainability proved crucial in theatres where spare parts were scarce. In North Africa, Hurricane squadrons operated for months with minimal resupply, cannibalizing destroyed aircraft for parts, and improvising repairs that would have been impossible on more complex fighters. One squadron kept a Hurricane flying for 8 months after it should have been written off, replacing damaged components with parts from 5 different wrecked aircraft, until almost nothing remained of the original airframe, except the data plate and serial number. The Western Desert Air Force, operating in conditions that destroyed more aircraft through wear and sand than enemy action, found Hurricanes could survive where Spitfires failed. The constant dust fouled precision mechanisms, abraded moving parts, and infiltrated sealed systems. Hurricanes, with their simpler construction and larger tolerances, continued operating. Ground crews developed techniques for protecting vulnerable components, wrapping air intakes in fabric filters, sealing cockpits with improvised covers and flushing engines with precious water to remove sand accumulation. Squadron leader Billy Drake, who commanded hurricane squadrons in North Africa and Italy, documented the maintenance challenges in his diary. Lost 2 hurricanes this, weak to engine failure, both from sand ingestion. The Merlin's supercharger intake sits low, and in desert operations the propeller wash from other aircraft kicks up dust that the next aircraft ingests. We've started spacing takeoffs further apart and using longer runways to reduce the problem. The Americans with their P-40s face similar issues, but their Allison engines seem slightly more tolerant of contamination. Still, we keep more hurricanes serviceable than they keep Warhawks running, so our sortie rate stays higher. The sortie rate advantage Drake mentioned appeared in every theatre where Hurricanes operated alongside other fighters. Official RAF statistics from North Africa in 1940s show Hurricane squadrons averaging 2.3 sorties per aircraft per day versus 1.7 for Spitfire squadrons and 1.4 for American P-40 squadrons. The difference compounded over time. A Hurricane squadron with 18 aircraft flew more missions per month than a Spitfire squadron with 24 aircraft. This operational advantage rarely appeared in historical accounts because individual sortie results drew more attention than cumulative effectiveness. A Spitfire pilot shooting down 3 German fighters in one mission made headlines. A Hurricane squadron flying 40 ground attack sorties in one day, destroying a few trucks each mission, never generated equivalent publicity despite arguably contributing more to battlefield success. The nature of ground attack operations virtually guaranteed anonymity. Air-to-air victories could be confirmed by multiple witnesses, camera footage, and wreckage examination. Ground attack results were impossible to verify accurately. Pilots reported trucks destroyed, buildings damaged, troops strafed, but ground forces rarely confirmed these claims. The enemy didn't publicize his losses. Bomb damage assessment was guesswork. Yet the cumulative effect was devastating to German and Japanese logistics. In Burma, where the campaign depended entirely on air supply due to impassable terrain, interdicting enemy supply lines became the critical air mission. Japanese forces, already operating at the end of tenuous logistics chains from Thailand, faced Hurricane squadrons that hunted supply convoys relentlessly. Every truck destroyed meant Japanese troops went without food, ammunition, or medical supplies. Every bridge blown meant delays measured in weeks as engineers rebuilt under constant air attack. Wing Commander Frank Carey, leading Hurricane squadrons in Burma during 1944, described the grinding effectiveness of interdiction operations. We weren't looking for glorious combat. We were looking for lorries. Find a Japanese convoy moving supplies forward, destroy it, move on to the next one. Boring work by fighter pilot standards. But every lorry we burned was ammunition the Japanese couldn't fire at our troops, food they couldn't eat, fuel they couldn't use. The Japanese army in Burma was starving by 1944, not because we cut their supply lines completely, but because we made every supply movement dangerous and expensive. They needed 3 lorries to move supplies that should have required 1, because we destroyed 2 out of 3 convoys. That mathematics eventually broke them. The mathematics of attrition warfare favoured aircraft that could fly constantly over aircraft that could fly fast. A Hurricane flying 2 sorties per day for 6 days delivered 12 attacks. A faster fighter flying 1 sortie per day delivered 6. Even if the faster fighter destroyed twice as much per sortie, the Hurricane's cumulative effect exceeded it. Over months of operations, this advantage became overwhelming, yet the Hurricane paid a price for this intensive utilisation. Airframe life, the number of flight hours before an aircraft required major overhaul or retirement, was substantially shorter for Hurricanes than Spitfires. A Hurricane in ground attack service might survive 200 flight hours before structural fatigue required withdrawal. A Spitfire in fighter service could fly 400 hours, but the Hurricane flew those 200 hours in half the time, generating twice the operational output before reaching the same fatigue state. This deliberate acceptance of shorter service life represented a philosophical shift in RAF thinking. Pre-war doctrine treated aircraft as valuable assets to be preserved. Wartime experience taught that aircraft were expendable weapons to be used intensively and replaced. The Hurricane's design, originally intended for longevity, proved ideal for intensive exploitation. Its ease of maintenance meant squadrons could fly aircraft harder, knowing repairs were straightforward. Its ease of production meant losses could be replaced quickly, The contrast with German aircraft philosophy was stark. The Luftwaffe treated aircraft as precision instruments, requiring careful maintenance and conservative utilization. German fighters flew fewer sorties per day, received more extensive maintenance, and were pulled from service at the first sign of fatigue. This approach preserved aircraft but reduced operational tempo. German squadrons with superior fighters often flew fewer missions than RAF Hurricane squadrons, negating their technological advantage. Operational research conducted by the RAF in 1943 calculated that intensive utilization of adequate aircraft produced better results than conservative employment of superior aircraft. A Hurricane squadron flying 40 sorties per day destroyed more targets than a Typhoon squadron flying 25 sorties per day, despite the Typhoon's greater individual striking power. The research recommended maximizing Hurricane sortie rates, even at the cost of increased attrition, because replacement Hurricanes arrived faster than replacement Typhoons. This calculation had human implications that operational researchers didn't emphasize. Higher sortie rates meant pilot exhaustion. Hurricane ground attack pilots in Italy during 1944 flew an average of one mission every 36 hours for months on end. Fatigue-related accidents increased. Pilot effectiveness declined as exhaustion accumulated. Squadron commanders struggled to balance operational demands against pilot welfare. Flight Lieutenant Robert Braham, who flew Hurricane night intruder missions over occupied Europe, described the psychological toll. The missions themselves weren't particularly dangerous compared to daylight operations. Flying low over France at night, looking for trains or vehicles, shooting them up, coming home, routine. But doing it every night, sometimes twice per night, never quite catching up on sleep, always slightly tired, that wore you down. After 3 months of continuous operations, I was making mistakes I wouldn't have made when fresh. Taking unnecessary risks because I was too tired to care properly. The Hurricane would forgive those mistakes, but only up to a point. The breaking point came differently for different pilots. Some flew 200 missions and remained sharp. Others began showing signs of combat fatigue after 50. Squadron commanders learned to recognize the symptoms: declining accuracy, closer brushes with disaster, irritability, withdrawal. The usual solution was rotating exhausted pilots to training units or staff positions, but in periods of intense operations, replacements weren't available. Pilots flew until they crashed, were shot down, or simply refused to continue. The stigma of combat fatigue, euphemistically called lack of moral fibre in RAF terminology, meant few pilots admitted they'd reached their limit. Those who did faced implicit accusations of cowardice. The Hurricane's forgiveness became a curse for these men. Because the aircraft tolerated pilot error, exhausted pilots could continue flying marginally effective missions long past the point where they should have been grounded. Their eventual breaking point often came catastrophically. Squadron leader James McLaughlin, a Hurricane pilot who had lost an arm in combat but continued flying with a prosthetic, wrote about this phenomenon in letters to his family. The Hurricane lets you get away with mistakes that would kill you in other aircraft. That's its great virtue and its hidden danger. A tired pilot in a Spitfire recognizes his deteriorating performance because the aircraft punishes errors immediately. A tired pilot in a Hurricane keeps flying because the aircraft compensates for his mistakes, until suddenly it can't, and he's dead. We lose more pilots to cumulative fatigue than we do to enemy action, but nobody talks about it because it sounds like weakness. McLaughlin himself died in July 1943 when his Hurricane crashed while attacking a train in Belgium. The official cause was listed as ground fire, but his wingman's report suggested McLaughlin had simply flown into the ground during his attack run, possibly due to fatigue or target fixation. He had been flying continuous operations for 5 weeks, sometimes 3 sorties per day. He was 27 years old and had flown over 300 combat missions. The human cost of the Hurricane's war rarely receives attention compared to the aircraft's achievements. The statistics focus on enemy aircraft destroyed, tanks knocked out, trains wrecked. But for every mission flown, a pilot risked his life in an aircraft that, despite its ruggedness, could be destroyed by a lucky rifle shot from the ground. Ground attack flying was brutally dangerous. Anti-aircraft fire didn't need to hit the aircraft directly. Disabling the engine or puncturing the cooling system was enough. A Hurricane with a dead engine at 50 feet altitude had no options. It crashed. The loss rates tell the story. During the Battle of Britain, Hurricane squadrons lost roughly one pilot killed or missing for every 12 sorties flown. In ground attack operations over France in 1944, Hurricane squadrons lost one pilot for every 35 sorties. That sounds better until you calculate cumulative risk. A pilot flying 100 ground attack missions faced nearly a 1 in 3 chance of being killed or captured. Those who flew 200 missions, as many did, were statistical anomalies who survived against mathematical probability. Yet pilots continued flying, partly from duty, partly from pride, partly because the alternative, letting your squadron mates carry the burden, was unthinkable. The Hurricane squadrons developed intense internal cohesion, bonds forged by shared danger and cumulative exhaustion. New pilots were hazed mercilessly, tested to determine if they'd break under pressure. Those who survived the first few missions were accepted into the Brotherhood. Those who didn't were forgotten quickly, their belongings packed up and sent home with minimal ceremony. Sergeant pilot Geoffrey Wellham, who flew Hurricanes during the Battle of Britain at age 18 and later wrote the memoir First Light, captured this brutal pragmatism. You couldn't afford to mourn. If you started thinking about the pilots who didn't come back, you'd go mad, so you didn't think about them. You packed their kit, drank their whiskey and flew their aircraft. Someone else would do the same for you when your turn came. It wasn't callousness. It was survival. The Hurricane kept flying, so you kept flying. That was the only certainty. This emotional detachment extended to the aircraft themselves. Despite the affection pilots felt for their Hurricanes, they recognized them as tools that would eventually be destroyed. Every Hurricane would someday be shot down, worn out, or crashed. The pilot's job was to extract maximum value before that inevitable end. This meant flying damaged aircraft that should have been grounded, accepting missions with minimal chance of success, and pushing both machine and pilot beyond reasonable limits. The RAF's approach to acceptable losses reflected this calculation. During intensive operations, monthly attrition rates of 30 to 40% were considered sustainable if replacement aircraft and pilots arrived at equivalent rates. This meant that every Hurricane squadron would be completely replaced, aircraft and pilots, roughly every 3 months. A few veteran pilots survived longer, but most were killed, wounded, or rotated out within that time frame. The replacement pilots arrived with minimal training, often less than 50 hours in type. They learned through brutal experience, flying missions alongside veterans who had little time for mentoring. The fortunate ones survived their first 5 missions and began developing combat skills. The unlucky ones died before learning anything useful. The Hurricane's forgiveness gave them slightly better odds than they'd have in other aircraft, but only slightly. This grim calculus underlay the entire British ground attack campaign from 1942 through 1945. The RAF accepted that destroying German logistics required sacrificing pilots and aircraft at rates that, in pre-war terms, would have been catastrophic. But the alternative was allowing German forces to operate freely, which meant longer war and more total deaths. The Hurricane squadrons bore this burden because their aircraft could sustain it better than any alternative. The final accounting of the Hurricane's war is thus necessarily incomplete. Official records list 14,583 aircraft built, roughly 4,000 lost to enemy action, perhaps 3,000 more lost to accidents and operational causes. These numbers omit the human dimension. Over 1,000 Hurricane pilots killed in action, several hundred more dying in accidents, thousands wounded or captured. They also omit the enemy casualties. Tens of thousands of German, Italian and Japanese soldiers killed or wounded by Hurricane attacks, hundreds of thousands more affected by logistical disruption. Was the exchange favourable? Strategically, undoubtedly. The Hurricane's contribution to Allied victory was disproportionate to its cost. But for the individuals involved, the men who flew them and maintained them and died in them, the strategic success offered cold comfort. They fought and died in an aircraft that history would largely forget, overshadowed by more glamorous types that contributed less to actual victory.